Your heart and your brain are connected in ways most people never consider until it's too late. Every beat of your heart pumps blood carrying oxygen and nutrients to your brain. Your brain, despite being only 2% of your body weight, consumes approximately 20% of the oxygen your heart delivers. When your heart doesn't pump efficiently, when blood vessels become damaged, or when blood flow patterns become disrupted, your brain pays the price. According to research from the American Heart Association, approximately 80% of people with vascular dementia have underlying cardiovascular disease that contributed to their cognitive decline. The connection is so strong that cardiologists now say what's bad for your heart is bad for your brain. Vascular dementia occurs when reduced blood flow damages brain tissue. Unlike Alzheimer's disease, where abnormal proteins accumulate in the brain, vascular dementia results from brain cells dying because they don't receive adequate oxygen and nutrients. This happens when heart conditions impair blood flow to the brain. What shocked me when I researched this topic is that many common heart conditions affecting people over 60 silently damage the brain for years before obvious dementia symptoms appear. The brain damage accumulates gradually. Small areas of dead tissue appear throughout the brain. Blood vessels become diseased. Eventually, the accumulated damage crosses a threshold where cognitive symptoms become noticeable. By that point, significant, irreversible brain injury has already occurred. In this video, I'll reveal 6 heart conditions that lead to vascular dementia in people over 60. Number 2 is so common, affecting approximately 1/3 of adults over 60, that most people watching this video either have it themselves or know someone who does. Yet few people realize it's silently damaging their brain. Before we start, I need to be crystal clear about something. This video is for educational awareness only. If you have any of these heart conditions, work closely with your healthcare team. Aggressive management of cardiovascular disease can prevent brain damage and significantly reduce your risk of developing vascular dementia. Now let's dive into the heart conditions that could be damaging your brain right now. Condition number 6, coronary artery disease that reduces overall heart efficiency. Starting with one of the most common heart problems in people over 60, coronary artery disease can lead to vascular dementia through its effects on overall cardiac function. Here's why this happens. Coronary artery disease occurs when the arteries supplying blood to your heart muscle become narrowed or blocked by plaque buildup. Plaque consists of cholesterol, fat, calcium, and other substances that accumulate inside artery walls over decades. As these coronary arteries narrow, your heart muscle receives less oxygen-rich blood. This affects how efficiently your heart can pump blood to the rest of your body, including your brain. Research from the Journal of the American College of Cardiology shows that people with coronary artery disease have approximately twice the risk of developing vascular dementia compared to those without coronary disease. Studies following thousands of people for decades found this increased risk persists even when coronary disease is treated. The mechanism involves reduced cardiac output. When your heart muscle doesn't receive adequate oxygen because of narrowed coronary arteries, it can't contract as forcefully. Weaker contractions mean less blood gets pumped out with each heartbeat. Your brain, sitting at the top of your body, requiring blood to be pumped upward against gravity, is particularly vulnerable to any reduction in cardiac output. Over years, chronic reduction in blood flow to the brain causes cumulative damage. Brain cells in watershed regions, areas between major blood vessel territories that receive the least blood flow, begin dying. White matter throughout the brain becomes damaged because the nerve fibers composing white matter require constant oxygen. MRI scans of people with coronary artery disease show characteristic patterns of white matter damage even before dementia symptoms appear. What makes coronary artery disease particularly insidious for brain health is that many people have no obvious symptoms. You might have significant blockages in your coronary arteries, reducing your heart's pumping efficiency without experiencing chest pain or other warning signs. Your heart compensates as much as possible, but your brain slowly accumulates damage from chronically reduced blood flow. Additionally, coronary artery disease often coexists with other cardiovascular risk factors, including high blood pressure, diabetes, and high cholesterol. These conditions compound the brain damage, accelerating progression toward dementia. If you've been diagnosed with coronary artery disease, understand that protecting your brain requires aggressive management of your heart condition. Take prescribed medications consistently, attend cardiac rehabilitation if recommended, control all vascular risk factors through diet, exercise, and medications. Regular monitoring ensures treatments remain optimized. Studies show that people with coronary disease who aggressively manage risk factors can reduce their dementia risk substantially compared to those who don't treat their cardiovascular conditions seriously. Condition number 5, heart valve disease that disrupts normal blood flow patterns. Moving to a heart problem that many people don't realize can affect the brain, heart valve disease can lead to vascular dementia through multiple mechanisms. Here's why this happens. Your heart contains 4 valves that control blood flow direction through the heart's chambers. These valves open and close with each heartbeat, ensuring blood flows forward efficiently. When valves become diseased, they either don't open fully, called stenosis, or don't close completely, called regurgitation. Both problems disrupt normal blood flow. Aortic stenosis, narrowing of the valve between the heart and the aorta, is particularly common in people over 60. The valve becomes stiff and calcified, restricting how much blood can exit the heart with each beat. This reduces blood flow to the entire body, including the brain. Mitral regurgitation, where the valve between the heart's upper and lower left chambers doesn't close properly, causes blood to leak backward. The heart must pump harder to compensate, eventually weakening over time. Research from the European Heart Journal found that people with moderate to severe heart valve disease have approximately 40% higher risk of developing dementia compared to those without valve disease. The risk increases with severity of valve dysfunction. The mechanism involves both reduced cardiac output and increased risk of blood clots. When valves don't function properly, blood flow through the heart becomes turbulent instead of smooth. This turbulence can damage blood cells and trigger clot formation. Small clots can break off and travel to the brain, blocking small vessels and causing many strokes that accumulate over time. Additionally, severe valve disease forces the heart to work much harder to maintain adequate blood flow. Over years, this chronic strain weakens the heart muscle, progressively reducing how efficiently blood gets pumped to the brain. What makes valve disease particularly relevant for brain health in people over 60 is how common it becomes with aging. The valves undergo wear and tear over decades. Calcium deposits accumulate on valve leaflets. Aortic stenosis affects approximately 2 to 3% of people over 65 and up to 5% of those over 75. Many people have mild valve disease that gradually worsens over years. During this progression, brain damage accumulates silently. If you've been diagnosed with heart valve disease, regular monitoring is essential. Echocardiograms track how severe the valve problem is and whether it's worsening. When valve disease becomes severe, surgical repair or replacement may be recommended. Studies show that treating severe valve disease improves not just heart function, but also cognitive outcomes, suggesting that correcting abnormal blood flow patterns protects the brain from further damage. Condition number 4, congestive heart failure that chronically reduces brain blood flow. Congestive heart failure represents one of the strongest risk factors for developing vascular dementia in people over 60. Here's why this happens. Heart failure doesn't mean your heart stops beating. It means your heart can't pump blood efficiently enough to meet your body's needs. The heart becomes weakened from various causes, including previous heart attacks, chronic high blood pressure, or valve disease. As the heart weakens, blood doesn't circulate through the body effectively. Fluid backs up in the lungs, causing shortness of breath. Blood pools in the legs, causing swelling. Most importantly, for brain health, reduced pumping efficiency means less blood reaches the brain. Research from the journal Circulation found that people with heart failure have more than double the risk of developing dementia compared to those without heart failure. Studies show that the more severe the heart failure, measured by how much the heart's pumping function is reduced, the higher the dementia risk becomes. The mechanism involves chronic cerebral hypoperfusion, meaning persistently reduced blood flow to the brain. Your brain needs constant oxygen delivery to function. Unlike muscles that can rely on anaerobic metabolism temporarily, brain cells require oxygen every second. When heart failure reduces cardiac output, the brain is one of the first organs affected. Brain imaging studies show that people with heart failure have reduced cerebral blood flow measurable on specialized scans. This reduced flow particularly affects white matter and deep brain structures. Over months and years, neurons in these regions die from chronic oxygen deprivation. White matter damage accumulates, disrupting connections between brain regions. MRI scans reveal characteristic patterns of injury, including white matter hyperintensities and brain atrophy. What makes heart failure particularly concerning for brain health is that it's often progressive. The heart function gradually worsens over years. As it does, brain blood flow progressively declines. Each step down in cardiac function corresponds to another step down in cognitive function. Additionally, people with heart failure often experience sudden worsening episodes called decompensations, where fluid accumulation and reduced cardiac output become severe. During these episodes, brain blood flow drops acutely. These acute reductions can cause small strokes or areas of brain damage that contribute to stepwise cognitive decline. If you've been diagnosed with heart failure, protecting your brain requires optimal management of your heart condition. Take diuretics and other heart failure medications exactly as prescribed. Monitor your weight daily to detect fluid retention early. Attend all follow-up appointments so your doctor can adjust treatments as needed. Control blood pressure strictly. Limit sodium intake. Studies show that people with heart failure who achieve optimal medical management have better cognitive outcomes than those whose heart failure is poorly controlled. The better your heart functions, the better your brain is protected. Condition number 3, atrial fibrillation that sends clots to the brain. Atrial fibrillation is one of the most important heart conditions linking cardiovascular disease to vascular dementia. Here's why this happens. Atrial fibrillation, often called AFib, is an irregular, often rapid heart rhythm affecting the upper chambers. Instead of beating in a regular, coordinated pattern, the atria quiver chaotically. This irregular rhythm has profound effects on brain health. Research from the Framingham Heart Study found that people with AFib have approximately 2.5 times higher risk of developing dementia compared to those in normal rhythm. The risk is even higher for people whose AFib is poorly controlled or untreated. The mechanism involves 2 separate pathways to brain damage. First, AFib dramatically increases stroke risk. When the atria quiver instead of contracting normally, blood pools in the heart chambers and can clot. These clots can break off and travel through the bloodstream to the brain, blocking arteries and causing strokes. Approximately 15 to 20% of all strokes are caused by AFib. Each stroke destroys brain tissue. Multiple strokes over time cause the stepwise cognitive decline characteristic of vascular dementia. But here's what shocked me when I researched this. AFib damages the brain even without causing obvious strokes. Studies using sensitive MRI techniques found that people with AFib have more silent brain infarcts, areas of dead brain tissue from unnoticed strokes, compared to people without AFib. You might have small strokes caused by tiny clots from AFib that produce no obvious symptoms at the time they occur. These silent strokes accumulate over years, gradually destroying brain tissue. Additionally, AFib reduces overall cardiac output. The irregular, uncoordinated contractions are less efficient than normal heartbeats. Less blood gets pumped to the brain with each beat. Over time, this chronic reduction in cerebral blood flow damages brain tissue, similarly to heart failure. What makes AFib particularly relevant to vascular dementia is how common it becomes after age 60. AFib affects approximately 9% of people in their 60s and up to 15% of those over 80. As the population ages, AFib is becoming increasingly prevalent. Many people with AFib don't even know they have it. The irregular rhythm might be intermittent, coming and going. You might have no symptoms, or symptoms so subtle you dismiss them as normal aging, fatigue, or stress. But even asymptomatic AFib increases stroke and dementia risk. If you've been diagnosed with atrial fibrillation, treatment is essential for protecting your brain. Anticoagulant medications, commonly called blood thinners, dramatically reduce stroke risk by preventing clot formation. Studies show anticoagulation reduces stroke risk by approximately 60 to 70% in people with AFib. Additionally, controlling the heart rate or rhythm improves cardiac output and brain blood flow. Take prescribed medications consistently. Never stop anticoagulants without discussing with your doctor, even if you feel fine. Attend regular monitoring appointments. The investment in managing your AFib pays enormous dividends in protecting your brain from strokes and dementia. Condition number 2. Hypertension that damages blood vessels throughout the brain. This is the condition most people already have. Hypertension or high blood pressure affects approximately 1/3 of adults over 60 in the United States. It's the single most important modifiable risk factor for vascular dementia. Here's why this happens. Blood pressure represents the force of blood pushing against artery walls as your heart pumps. When pressure remains elevated over years, it damages blood vessels throughout your body, particularly the small vessels in your brain. Your brain contains thousands of tiny arteries, each smaller than a human hair, delivering oxygen to deep brain structures. These small vessels are exquisitely vulnerable to pressure damage. Research from The Lancet shows that people with chronic hypertension, particularly high blood pressure in midlife that persists into later years, have up to 60% increased risk of developing dementia compared to those with normal blood pressure. The relationship is so strong that researchers estimate controlling hypertension could prevent approximately 20% of dementia cases worldwide. The mechanism involves small vessel disease and cumulative brain damage. Chronic high blood pressure batters the walls of small brain arteries with excessive force. Over years, this causes structural changes in the vessel walls. The walls become thickened and stiff. The vessels lose their normal ability to dilate and constrict appropriately in response to the brain's changing needs. Eventually, these damaged small vessels can become completely blocked, causing small infarcts throughout deep brain structures and white matter. Each small infarct kills a small area of brain tissue. Individually, these infarcts might not cause obvious symptoms, but as they accumulate over decades, they destroy enough tissue that cognitive symptoms emerge. MRI scans reveal this damage as white matter hyperintensities, bright spots on specific scan sequences indicating areas where brain tissue has died from inadequate blood flow. Additionally, chronic hypertension increases risk of larger strokes by damaging major arteries supplying the brain. The same pressure damage affecting small vessels also affects larger arteries, promoting atherosclerosis and making vessel walls more prone to rupture or blockage. What makes hypertension particularly insidious for brain health is that it's called the silent killer for good reason. You can have dangerously high blood pressure for years without any symptoms. You feel completely normal while your brain accumulates progressive damage from battering blood vessels. Additionally, many people don't treat their hypertension adequately, even when diagnosed. They take medications inconsistently. They don't monitor their blood pressure at home. They don't work with their doctor to find the optimal medication regimen achieving target blood pressure. Studies show that achieving blood pressure control dramatically reduces dementia risk. Research found that intensive blood pressure lowering, targeting systolic blood pressure below 120 mmHg, reduced risk of mild cognitive impairment by 19% compared to standard treatment targeting below 140. If you have hypertension, protecting your brain requires achieving and maintaining blood pressure control. Take prescribed medications every single day without skipping. Monitor your blood pressure at home weekly, keeping a log to share with your doctor. If your blood pressure isn't controlled on your current regimen, work with your doctor to adjust medications until targets are achieved. Don't accept good enough blood pressure control. Optimal control provides maximal brain protection. Lifestyle changes amplify medication effects. Reduce sodium intake to below 1,500 milligrams daily. Lose weight if overweight. Exercise regularly. Limit alcohol. These changes can reduce blood pressure significantly, sometimes allowing reduction in medication doses while maintaining control. Remember, every mmHg reduction in blood pressure reduces your brain damage risk. The effort invested in controlling hypertension pays enormous dividends in maintaining cognitive function as you age. Condition number 1, atherosclerosis causing carotid artery stenosis. Taking the top position, atherosclerosis affecting the carotid arteries in your neck represents one of the most direct pathways from heart disease to vascular dementia. Here's why this happens. Atherosclerosis is the process where cholesterol, fat, calcium, and other substances build up inside artery walls, forming plaques. These plaques can develop in arteries throughout your body, including the coronary arteries supplying your heart and the carotid arteries running up both sides of your neck, supplying your brain. Your two carotid arteries deliver approximately 80% of the blood your brain receives. When atherosclerosis affects these critical vessels, the consequences for brain health are severe and direct. Research from Stroke Journal found that people with significant carotid artery stenosis, meaning narrowing of these vessels by 50% or more, have dramatically increased risk of both stroke and vascular dementia. Studies show the risk increases with severity of stenosis. The mechanism involves both reduced blood flow and embolic events. As plaques grow in the carotid arteries, they progressively narrow the channel where blood flows. A severely blocked carotid artery might allow only a trickle of blood through to your brain. This chronic reduction in cerebral blood flow causes cumulative damage similar to heart failure, gradually killing brain cells that don't receive adequate oxygen. Additionally, atherosclerotic plaques are unstable. The plaque surface can crack or rupture. When this happens, your body tries to repair the damage by forming a blood clot over the rupture site. Pieces of this clot, or pieces of the plaque itself, can break off and travel up into your brain. These emboli block smaller arteries in the brain, causing strokes. Even tiny emboli too small to cause obvious stroke symptoms can cause silent infarcts that accumulate over time. What makes carotid atherosclerosis particularly concerning is that it often produces no symptoms until it's very advanced. You can have severe blockages in both carotid arteries without feeling anything wrong. The blockages develop slowly over decades, allowing your brain to partially compensate through other blood vessels. But compensation is incomplete. Brain damage accumulates silently. Additionally, the same risk factors causing carotid atherosclerosis typically affect the entire vascular system. If you have significant carotid disease, you likely have atherosclerosis in coronary arteries, in arteries supplying your legs, and in small vessels throughout your brain. The brain damage results from multiple sources simultaneously. Studies using ultrasound to screen for carotid stenosis found that measuring carotid artery thickness and plaque burden predicts future dementia risk. People with the most severe carotid atherosclerosis had the highest rates of cognitive decline over subsequent years. If you have risk factors for atherosclerosis, including high cholesterol, hypertension, diabetes, smoking history, or family history of vascular disease, discuss carotid screening with your doctor. A simple, painless ultrasound can detect significant stenosis before it causes stroke or accumulates extensive brain damage. When severe stenosis is found, treatments are available. Medications, including statins, antiplatelet agents like aspirin, and aggressive risk factor control, can stabilize plaques and reduce stroke risk. For very severe blockages, procedures including carotid endarterectomy or carotid stenting can remove or bypass the blockage, restoring normal blood flow to the brain. Studies show these procedures reduce stroke risk and may improve cognitive outcomes by preventing further brain damage. The key is detecting carotid disease before irreversible brain injury occurs. What you must do next. If you have any of these 6 heart conditions, or if you have risk factors that make these conditions likely, protecting your brain requires immediate action. First, ensure all heart conditions are optimally managed. Take prescribed medications consistently every single day. Never stop cardiovascular medications without discussing with your doctor. Attend all follow-up appointments so treatments can be adjusted as needed. Second, aggressively control all cardiovascular risk factors. Achieve blood pressure below 130/80 millimeters of mercury. If you have diabetes, maintain A1C below 7%. Lower LDL cholesterol to target levels, typically below 100 or even below 70 for high-risk individuals. Stop smoking immediately if you still smoke. Third, make lifestyle changes that protect both heart and brain. Exercise regularly, aiming for at least 150 minutes of moderate intensity activity weekly. Follow a Mediterranean-style diet rich in fruits, vegetables, whole grains, fish, and healthy fats. Maintain healthy weight, limit alcohol intake. Fourth, discuss screening for undiagnosed conditions. If you haven't been checked for AFib, ask about screening, particularly if you have risk factors. If you have multiple vascular risk factors, discuss carotid ultrasound to check for stenosis. Fifth, understand that protecting your brain requires lifetime commitment to cardiovascular health. These aren't temporary changes. Optimal management of heart conditions must continue indefinitely to prevent brain damage accumulation. Studies consistently show that people who aggressively manage cardiovascular disease throughout their 60s, 70s, and beyond maintain better cognitive function than those who don't prioritize heart health. Your heart and brain are connected. Protecting one protects the other. Which of these heart conditions surprised you most in terms of dementia risk? Do you have any of these conditions? Share your thoughts in the comments below. If this information helped you understand the heart-brain connection, please like this video and subscribe to our channel for more evidence-based health content for people over 60.